Apa?
So
3HT
review
conduction. Bagi ada tu.
is week 2 and week 3 materials.
Pun week 3
We have
kan?
covered basic concepts of conduction, convection, and radiation.
Tanya
And
doktor
Dapat.
nak
associated
ada
laws,
password.
Boleh tutup
importance
lah
and
iPad ni.
applications of heat transfer. So conduction occurs around us.
Mana ada
So
tu
is
Pak?
convection. So is
Tak
radiation.
ada, so aku mana tu
So
ada
I gave
bagi
you an
lepas tu.
example. Even if I'm staying in this room, my
Cari
walls
tu
are
kan
being
nak orang tanya.
heated by the sun. So it could be
Cik, duduk
radiation.
pun tak ada.
And there's conduction through the wall.
Apa kita
Bodoh
hantar
kita-
pram
And then there is
ke ni?
convection because it's
Kita
air
main
conditioned
teka-teka
room.
nama-nama Pokemon.
It's
Tu lah
convection.
password dia.
Radiation is also
Aku
occurring
share lepas
because
ni
all
Meowth tu.
surfaces
Apa?
at 0 Kelvin and above emits radiation. However,
Dia
because
suka
the heat
Pokemon
is being
tu.
removed by the air conditioning system,
DP Twitter
so
Pokemon siap.
the radiation is negligible. What is significant is
Barang Pokemon
convection.
Digimon lah tu.
Also, when you're
Ya
boiling
doh,
water,
aku sedih Digimon Power
kettle,
Hero.
Lepas ni dia
what
pakai
else?
Blastoise
Hill.
tu.
When you're driving, there is
Mancap.
the engine heating up. Yeah, it's all
Aduh.
around us. Even the electrical power that you
Kalau
get
Digimon
involves
lagi
heat
lah
transfer.
seronok. Main teka.
Now let's have a look at general conduction, which involves Fourier's law. You must remember Fourier's law. So the unit here is watt, because you have the area there. K is in watt per meter per
What?
Kelvin.
ADTDX.
Area
What?
is in meter squared.
DN.
Is Kelvin, meter. I should do
Oh.
watt. Heat flux. So heat conduction per unit surface area in x direction or any horizontal direction for that matter will be in this form, which is the unit watt per meter squared. For plain solid wall or plain
Ni baru
stationary
ke tu?
fluid wall, the temperature profile
Kita bagi
is
kan?
linear. There is
Mesti
no
tak.
heat generation. Steady state, then the temperature profile is linear. Now, if you know the direction of heat from a higher T to a lower T, then you can just use this equation. This is for steady state, no heat generation. Heat transfer per unit length is given as watt per meter, or per unit volume, watt per meter cube. Now, general convection, you will know Newton's law of cooling. Newton's law of cooling.
Smart.
This is in watt because H is the convective heat transfer coefficient, which is in watt per meter squared per Kelvin. Positive if surface temperature is higher than the moving fluid and vice versa. Then there is general radiation, heat transfer from any surface, assuming it is a black body, you follow Stefan Boltzmann. If it's a real body, you have the emissivity in there. So T is in Kelvin.
Black body
Here,
apa
if
ya?
you forget to change, you are still fine. Because,
Yes, yeah, man.
S plus 273 minus T infinity plus 273, it doesn't matter because it's only a difference. But over here, it makes a huge difference. So it's a good practice, to convert all your temperatures into Kelvin. And from any real surface, you have that. And for a body, T surface surrounded by another
Kau
large
itu saya.
body T surrounding, the net heat transfer from the smaller
Shut
body
your
is this.
fucking mouth.
Net from the smaller body. If it's a
Cik
negative,
Aizan, kau
then
itu
that
saya.
means the smaller body is receiving heat from the surrounding.
Aku rasa
The
scripted
radiation
kat
heat
tu.
transfer coefficient is sometimes
Kau
used.
tengok lah, ada banyak
So here,
orang buat teori.
defined by
Slow motion kan
multiplied
video
by the
tu lah,
Stefan
nampak.
Boltzmann.
Macam
And
standby
the
untuk
rest is
kelempang habis.
also given in your textbook.
Sebab orang kata dia nak
In
viewers
fluid,
suka
both
tengok.
convection and radiation may occur simultaneously. Thus, the total heat transfer must consider both modes. For heat transfer analysis, identify the boundary and the modes of heat transfer that enters or leave the boundary surface. As you can see here, you mark the imaginary boundary. You learn that in your term 1, your imaginary boundary or your control volume, in this case control surface. You identify what goes into that.
Ngantuk dah tengok ni.
That volume or surface that you are analyzing
Dah sejam
and
dah
what
Pat.
goes up,
Don't
you
worry.
can do an energy
Dah
balance.
sejam dah apa?
For conduction heat transfer, which we did last week and this week, we
Tak
call
payah
the
tidur
heat
benda ni.
diffusion
Kau dah sejam dah apa?
equation. Unsteady, three-dimensional.
Lagi sejam
We
lah
have
main
this.
lahan.
Aku dah tidur tadi
This
sekejap.
is the basic
Tak awak
equation.
mana tidur habis
Isotropic
tidur lah. Dia
material,
macam
we
dekat mana
just
sekarang ni.
keep the
Tak nampak masa
subscripts
depan
X,
subjek ni.
Y, and Z.
Pisang ni.
So now, if you have in cylindrical coordinates, that
Dia tak
is
risau tu
and
last time tu.
spherical
Pondok
coordinates,
sama.
this
Tak dapat
note the
conversation drop terus.
difference are squared down there in the denominator. The full conduction equations can only be
Equation apa
solved
tu?
up
Q.
to
Q dot eh?
two variables. Yes. So
Q dot
meaning
lah.
if you have this, you can have steady
Conduction
state,
heat transfer.
no heat generation, two-dimensional,
Oh,
or
heat transfer.
one-dimensional, unsteady. You learn that in your calculus. Only in two variables.
Ni yang
Same here,
transient.
yeah.
Bukan
Could
yang
be
bukan
two-dimensional, steady
apa kan?
state, no heat
Formula
generation,
conduction kan.
or unsteady one-dimensional.
Bukan Fourier law punya kan.
There are 6
Forest
types
law
of boundary
yang
conditions.
kita belajar
Whether
ni.
you have constant surface temperature defined, which is called
Dia
Blake
kita
type
basic
boundary
equation
condition.
memang yang tu man.
Constant heat flux at
Cuma
the
beza
surface,
dia
which is the
nanti akan
derivative
kita
of the
pilih ada
temperature is
transient
given,
ke
or zero is given, yeah.
steady
Convection
ke
is
no
surface
heat
condition.
generation
We
ke.
haven't gone through that explicitly,
Paling
but you
panjang
may have
tadi
a look
heat
in your
diffusion equation eh.
textbooks. I think they have an example. Yeah, radiation boundary condition, same. An example, a
Q
work
dot.
example is given in the textbooks. Interface boundary condition, that means at the interface of two different
Dia nak review
materials,
je ni yang tidak ajar balik kan.
must be the same. And we have some generalized boundary condition. All 6 boundary conditions are described explicitly in your
Ni dia
textbook.
just go through.
So that's just a review of what have been covered this past
Aku
3
rasa dia
weeks.
bagi yang note yang dia
Should
bagi
be
ni
3
ni
weeks.
tu.
But I am I'm finishing earlier.
Note ajar
Don't
lain
worry,
anjir.
there will be an example later on.
Kau tengok lah tu 309 words. Words. Oh,
Okay.
okay.
Now I want to share with you.
Ingat 309 page.
Right.
Okay.
Gila babi buat buku
Want to
tag kan
share
doktor.
with you previous
Satu week 300 page babi.
previous assessment question. Okay, this is from last year, 2020 to 2021, semester 2, so a year ago. Yeah, open book test online, but you only given one
Not
question
soft.
at a time.
Dah tu asal bagi soalan. Apa
So that
dia?
means you cannot go back to work on it, unlike a face-to-face exam. Face-to-face exam, you're all given the question, and then if you finish question 3 earlier, then you can go back to question 1, but not online. You're given just, excuse me, that allocated time, whether you can do it or not, that's it. You cannot go back. You submit, and then for the next test, question 2. Yeah. Now here, this cover the materials for the test 1. Similar. Steam flows in a tube at an average temperature of T infinity 1, with a convective heat transfer coefficient H1. The outside
Agak tadi
surface
aku
of the
mimpi
tube
dengar
is
suara
exposed
dia
to
mengajar.
surrounding air at the temperature of T infinity
Ni
0.
bodoh.
Semangat heat transfer.
This is inside. With
Aku
convective heat transfer
duduk
coefficient
tidur.
HO.
Dengar tu.
Table 1.1 illustrates the tube specification. It's a length
Semangat ya
L,
gantang.
radius R1, outer radius R2, thermal conductivity K, initial temperature T
Apa ya, aku
high.
tengok pun.
So this is a very abstract first part.
Tapi
Express
assumption je.
the mathematical formulation and 4 assumptions to
Dia sebab
describe
mathematical
the conduction
formulation tu
heat
man.
transfer within
Oh,
the
agak
hall. Do not solve, and yet many students solve it, wasting time. You are just supposed to express the mathematical formulation and 4
Semangat
assumptions.
ya sayang.
So what do you do here?
Semangat.
What coordinate should you utilize here?
X.
I can't call names. Why? Because I don't have the final name yet. Yeah?
Cylindrical.
Cube. Steam flow.
Maybe I can call. Is Afif Danish here? You came last Thursday.
Apa
Alhamdulillah.
Danish?
Yes.
Itu atas sekali tu pisang
Which
aku ni.
coordinates? First we have to identify which
Bodoh, dia
coordinates
tanya aku
should
ni
we
aku tak
use.
dengar apa tadi awal ni. Bodoh Syal.
Dia tanya kau.
Tak ada, kalau dia panggil nama aku,
cylindrical
aku
or
tadi dah
spherical?
tak dengar apa.
Baik.
Afif ni.
Radius. Dia
Cylindrical. Okay. So we have a cylindrical coordinate. Now, let's have a look at the end. I want to give example. Okay. You can see this. So insert. We have a
apa itu podcast babi.
cylinder.
Itu memang bedtime story tu dalam petang.
Bill is that. And then we want to have another one.
Mekatronik dia tak dikira-kira kan.
Yakin ni kau.
Tak, aku
Yakin
tanya
dia.
korang ni.
Oh, not like that.
Dia
Saya
nak
tengok
buat apa
nota
ni?
Bit difficult,
nota
Sebab it's a
Doktor Mat
cylindrical
ada
shell,
satu
yeah.
je, satu
So what we can do is
satu slide note yang dikira
the
ni.
front. Oops.
Podcast gak ah. Mantap.
Podcast gak
Typical.
bagi
Let
aku.
me see.
Dah
Insert
babi.
a circle.
Latih macam ni. Pucik je.
Then
Lepas
I
raya
make
memang
another
face to face.
circle.
Hmm.
Yeah.
So
Okay.
declare group cohort
I
tu
wish you
dah
can
nak
draw
gaduh
these.
tu.
Aku
Okay.
rasa
I
paling
have a
selamat
tab,
sana
but
kalau
we
dia
can
buat
never use it.
final.
because
Final
I
saja
don't know
lah.
how. It's too
Ya,
complicated.
orang
custom
yang
je.
ada
Let's
clash
see.
tu kesian kan.
Tak adalah macam nak belajar face to face macam agak
Okay. Let's
sudden
consider
lah.
this circular. So
Macam
this is, let's say,
clash
the
Zat
front
ada
picture
view.
lah.
clash je.
Next,
Aku ada clash.
what do we need
Oh,
to
ada
do?
clash tak?
Hamzah ada clash. Rodi ada clash. Ha?
Express the
Siap nak.
mathematical
Machine
formation
lah. Aku
and
tadi
four
pukul 8
assumptions.
machine. 8 sampai 9
Do
machine.
not solve.
8
nasib
sampai
baik.
10.
Aku rasa
It's a cylinder, right?
Jam
aku
ah.
ada
So it's a
buku
cylinder.
mesin tapi bukan yang buku tebal tu lah.
Betul?
Ya aku hantar. Gambar.
Okay.
Saya,
Machine
This
kalau nak beli
cylinder.
baru tu RM46. Mahal lah.
Siapa pergi ambil mesin tak?
Tak ada.
Oh, Rodi
Ya.
tu tak.
Tak. Dia ambil
You have that,
blade.
right?
Fit tu.
That should be it. Is that the answer?
Rasanya.
Fit tu dah susah.
Is that the answer?
Ya.
Tapi dapat Dr. Noisy lah.
Dia tanya is that the answer guys?
Jawab je yes.
Apa dia tanya? Oh, kalau berlubang tengah
Donut.
Anyone?
Dia tanya
We
apa
have
tu?
to call out.
Kita tanya apa ni?
Is it the answer?
Oh,
Is that
bawah
the
tu.
answer?
Hmm.
See, where am I going to go?
Tak lah kan.
Is Ahmad Amar here?
Sikit lagi.
Ahmad Aiman
Aizul
lah.
Amirin, are you here?
Aduh.
Or Yi Chia Zen, are you here?
Sikit-sikit. Ni maknanya apa with respect
Kalau
to Z,
matematik-
Z dengan V tu potong kan.
Yes. Tell me.
Tinggal R je
Because the
kan.
question asks for an expression
So apa dia ke arah mana sekarang ni?
for the problem
Dia
and four
tengok
assumptions.
kita nampak sekarang ni R je kan. So yang Z apa
Yeah,
V
to
dengan
describe the
Z tu boleh
conduction
potong.
within the wall. That's all. How
1D
many marks
R.
is that? That's 7 marks.
Belum
That's a lot.
lagi. Dia kan ada lagi.
Steady state potong kanan tu.
What should I do with this equation? Leave it?
Cuba bagi kita orang baca dia punya.
Tadi tunjuk sekejap je. Ingat
Aspek
apa-apa
dia kata.
share.
Jazio,
tu
are you here?
Condition dia. Oh,
Jazio
Jazio,
Bede.
teammate kau.
Jazio?
Jazio Bede Jansus.
It's not here. Sheikh
Aku
Muhammad
tanya
Shifil,
Lucy,
are you
bye.
here?
Baru lah siap.
Oh, I'm not calling you to the guillotine, you know. I'm calling you to suggest. Be brave.
Guillotine apa?
Shifil is not here.
Alah,
Yeah. Okay, Prem, you want to try?
Betul lah Prem kat canggih.
Yes,
yang,
Ustaz.
yang
Okay,
pirate
go
tu
ahead.
lah. Pirate kena
I think this is not
potong kepala.
the
Yang
right
dia letak
answer
kepala,
because
lepas
we
tu
are not expressing with the assumption.
Okay, give me what assumptions do we need?
But actually we already
Relate
reached
lah.
one
Apa
getting the
one dimensional, one dimensional.
thermophysical properties. We already factor out the K.
Okay, so constant thermophysical.
Oh, constant
properties.
thermophysical tu K lah.
And
Dia bagi
the
case
first
semua
one
kan?
should be the steady
Oh.
state.
Okay, steady state. Okay, let's look. Steady state.
Saya potong ke kanan lah.
Then the question also didn't mention any
Dia dapat,
other
dapat
material
version
involved, so this will be
lagi,
isotropic material.
Dia repeat
Okay.
lah Baris.
They want 4.
Oh, kalau tak bagi tahu material
And
isotropik
since the steam, I think
Allah.
the steam is flowing
Siap,
in
Prem.
one direction. We can
One
assume
dimensional in
it's
arah.
one dimension problem.
One dimensional in because it's cylindrical.
Yeah.
Remember I said
Yeah.
Arah.
In R.
In radial direction.
in R. Right.
Yes, okay.
So,
No heat generation.
then you
Ke
have
ada?
this. There should be one more, but you know,
Yes.
No heat
No heat
generation.
generation.
they
But,
want just 4, right? because the
Yeah.
question asks for four assumptions to describe the conduction. So you can have 5 because probably isotropic material, most people, most lecturer don't consider because already isotropic. So here what?
Tapi kalau dia tak mention material tu
No
pasal
heat
macam ni.
generation.
Okay, right. Okay, so with that, you have that, correct. Then you get 7 marks
Apa baik siap Prem.
Baik, 2 prem.
for that question.
Yang constant thermophysical property sebab apa?
Mathematical
Bagi
formulation
tahu
to describe the
conductivity.
conduction heat transfer
Sebab
between the
equation
two
tu
wall.
dia
Okay.
fit out okay.
Now the next
Ni
one,
macam nak tahu lah.
they
Kalau
didn't
basic
even
memang
ask
dia tu kot. Constant
boundary condition.
thermophysical.
Well,
Tak mention
actually, it's needed to have the boundary condition. I think it wasn't
Oh,
clear.
dia tahu.
So you need boundary condition.
Heat generation. Sebab tak bagi tahu.
What's the boundary condition? Yes, Prem is active, so proceed Prem. Maybe the others is a opportunity for you, yeah, to be brave, to test. Even if you are wrong, then the person who is afraid to make mistakes
Apa tu?
never learn anything new.
Ni lah. Boundary
Oh,
What
boundary
is the boundary
condition.
condition?
R1, R2 lah probably.
Naruhan R2 lah. Ni dah bagi.
Sebab dia
Boundary
in
condition
R
there
direction.
should be two. One within the tube and one the outer layer.
Yes, so here, okay, here with the convective heat transfer. Convective heat transfer, yeah. So that should involve convection boundary condition for the inside and the outside.
Conductivity.
So you have both convective
Is exposed to
convection
surrounding
boundary
air.
condition. So how do you provide convection boundary condition?
Oh, heat generation.
Yeah.
Steady state.
So one
Saya nak tahu
at
steady state lah.
R
Sebab dia tak
is
tak
equal
ada.
to R inside. Yes. Then what we have? We have convective PC. At R is equal to R outside.
Aku.
We have
R1,
also
R2 je.
another convective PC. What is convective PC? So you have to go back.
Jadi
Siapa tu?
Eddie eh?
ID.
Sheet off.
Isha.
Boundary condition. Where is the boundary condition? Oh, there. Convection. That's the boundary condition number 3. Minus K dt dx is equal to that. So how do you write
Tak
that?
ada. Tengok cerita orang tak
So
ada.
we go back here.
Screenshot.
Yeah. Tahu lah.
So we insert equation
Oh, ada convective.
minus K
Spare.
what? dt
Apa ni terus eh? Apa terus
R
eh?
is equal to H. What was the boundary condition in your textbook? No, not that. Sorry. Yeah. H T infinity minus T. So this is T at that, right? So you just apply that.
oh dah lepas ni terus
Oh,
Oh, sorry.
non-stop.
Should have yours, that. Okay.
Yeah.
Terus.
Infinity minus
I rehat lah. Like.
Babi.
T. Yeah. So you can have a look at that. T 0. That means at that location at any time. It is unsteady but steady state, right? T at Ri. Inner. T, the boundary condition given was be specific. T infinity 1. So you have to name as T infinity I inside. Sorry. That's the boundary condition. Yeah.
Macam-macam siap.
At see, not complete. At R is equal to R I. Yes, that's the one. So here, this is convective boundary condition. At r is equal to Ri minus k dt dr is equal to h T infinity minus dRi. So the same goes here. Yeah, but this time if r is equal to r outside, yeah, T infinity out is equal
Mana
to
masuk PDF ni man?
minus T out.
Pokemon.
Yeah.
Pikachu.
Okay, so your boundary condition, then only you get 7 marks. Now next, a
Sebab tu
cylindrical
tak
heat
gambar ayat.
element, definitely heat generation, with 40 centimeter length and 5
Baik.
mm diameter. There's no heat generation here. Has a heating capacity 0.8 kilowatt. Referring to table 1.2, the element is immersed in water with mass M and initial temperature Ti in various heating processes. During the processes, the surface temperature of the element is fixed at Ts. Yeah. Choose one of the processes in table 1.2 and determine the time needed to raise the water temperature to 80 degrees C in hour. That means how long does it take? Not in second, not in minutes, in terms of hour, 1.5 hours, 1.8 hours. I mean, choose any one of these. Yeah. So how do you go about this? Doesn't look like heat transfer, does it? Looks like thermo. Heat transfer is in thermodynamics. So how do you go about solving this? Yeah, students get a bit of a surprise when they saw this question because this actually is something to do with thermodynamics. Heat transfer, 40 centimeter length, 5 meter diameter. So it's a cylinder, has a heating capacity 0.8 kilowatt. Yeah. So the mass, it has the mass, ST initial. Yeah. The surface temperature of the element is this. 280 degrees an hour, in hour. How do you go about? Remember the heat capacity? I'm assuming. Oh, this is mass of water. Yeah, this is mass of water. So how do you raise the temperature of the water from 20 degrees to 120? You did in thermo 1, if I'm not mistaken, in the first few chapters. Yeah. Q is equal to M Cp delta T. Or Cp, Cv is the same for water. You have to find the specific heat of water. You have the initial final temperature. You have the M. You can find the heat. No?
Rosak siap.
But you want to raise it to 80 degrees.
Oi.
Oi.
Rosak.
Mancing
Not
apa
120.
tadi?
Kencing kat handphone siap.
How long does it take? So that one
Cool.
is actually thermo 1. I'm not going to go through that.
Sebab aku pakai
Go this.
earphone
It's a bit out of the
earphone
box.
biasa, bukan earphone.
And then explain why. It's 13 marks. Yeah? But if you scored this, you got 7 already there. And then explain why the heat transfer coefficient changes during the heating
Buka
process
PDF tadi.
as calculated in part B2 here.
Allahu Akbar.
No
Kenapa,
calculation
Wan?
needed. So you don't have to calculate, you just need to
Kenapa?
explain. It's 5 marks. Why the heat transfer coefficient changes. The convective
Buka
transfer
word
coefficient
tadi,
at the
Rosa.
beginning and at the end of the heating process
Apa kata bagi
by
word tu sekali
considering the
tu?
initial
Aduh.
and final temperature of the water
Yang
respectively.
dia dah buat jawapan tu.
Sumpah
So the
tu.
H changes during the heating process.
Dia tak bagi
as
apa-apa yang macam
calculated
buat
in
kita
part
malas belajar
B2.
babi.
Ya.
Saya terbiasa kau. Ibu ni macam ni.
Okay.
Buka balik word tu.
This,
Sikit-sikit. Buka sikit. Aduh, tak nak buka pula. Lah, mesti makin kamera ni.
This is another one. It's 2 questions.
2 soalan je.
Steam at an average temperature at
Oi, dua soalan
250.
je,
Please have a
weh.
look at that. Maybe you can
20
find that as a
markah,
homework.
Syah.
Yeah? So be interesting. Steam at an
Forward.
average temperature of 250 is flowing through a stainless steel pipe whose inner and outer temperature are 4 centimeter and 6 centimeter
Google Rush.
respectively. Still another cylindrical coordinate. The heat from the pipe. I'm going to stop this. It's too long. Okay. The heat from the pipe is lost to the surroundings at 30 degrees C by natural convection and radiation with a combined heat transfer coefficient 20 watt per meter squared Kelvin. In order to reduce the heat loss, this pipe needs to be insulated with a suitable material to keep the temperature of the steam at 250 degrees C. The heat transfer coefficient at the inner surface of the pipe is estimated to be 180 watt per meter squared per Kelvin. This is H. You have been informed that a sprayed or formed in place type of insulation, I cannot mark this, would be used. Justify the specific type of insulation material that you have selected. So, either sprayed or formed in place type of insulation. You have to justify why. So here, again, is a cylindrical, but this time stainless steel pipe with inner and outer diameters 4 and 6, which is thickness of 2. So it has a thickness of 2 centimeter. So inside temperature 250 and outside, no, there's no temperature outside, or the heat to the surrounding at 30. I cannot highlight. I don't know why while I'm sharing. So this is 20 marks for this part. And then calculate the temperature on the outside. So here, the first thing is, like before, it's good to have a schematic diagram. So you have a pipe, right? So you have your assumptions. Even though the assumptions have not been requested, you still must present the assumptions. In any heat transfer analysis, there must be assumptions. If they do not ask explicitly, these assumptions may be worth 1-2 points. It's still worthy of your time. When you are poor, any marks count. So you have this one-dimensional. Now you need the boundary condition. So some students say assume the inner surface temperature is 250, outer surface temperature is 30. But it's not, right? Because this is a surrounding, it's not the wall of the pipe. So be careful, In order to reduce, there needs to be insulated to keep the temperature steam at 250. So actually, when you have this, so this is the pipe, this is insulation. So you may assume that the wall is very thin. So this inside is stainless steel pipe. But how thin is it? It says 2 centimeters. So you need another one. You need to another. Okay. So you need another one. Okay. Bring forward, send to the back. I want send backward, right? Okay. Okay. It's a bit difficult. Bear with me. Shape format. Shape fill. Let's see this one. And then I need to insert another circle because I want to take that. Okay. That's one.
Aduh.
And then I want to insert another one.
Kau salin ni.
Just assume they are circular. My
Ah,
drawing
nampak
is really poor.
Jadi
Yang tu tak
babi.
bodoh sebab aku nak tahu soalan pun tak sempat.
Tak salin tu.
Dah
Mana
simpu
nak
tu. Ada salin tu sebenarnya.
Mana nak
Why can't I
menyampai?
have
Tu ada, nanti bagi je lah.
Nanti dia baris.
Makan seorang sekejap.
I
Terdiam
want
babi.
to have this as
Goy.
insulation.
Data
Oh, I cannot have.
bawa ais sekali.
I don't know why.
Hah?
Sucks,
Pelik
yeah.
saya lukis.
Doktor. Aduh,
Doktor,
kata hebat sangat.
Doktor nanti bagi notes.
Okay, let's just say this is
Joking.
yeah.
Try buat yang tu.
And this is
Kita
I
orang
cannot
nak
have no
nak
feel.
salin tu,
Why is
doktor.
it?
Hah?
Shape outline.
I don't
No
know.
feel.
Doktor,
Okay, just have
doktor.
that. Hmm.
Apa macam tu siap?
Apa
Yang-
apa ni?
Apa benda ni?
Nak
Ni buat bomboloni
Dia
kan.
nak
Sebelah tu bordonat, kanan ni bomboloni.
apa 3 tingkat siapa benda
Okay,
ni?
that's all I can do. Sorry, yeah.
Apa benda
So
ni?
let's say you have steam in this inner circle, inner pipe,
Ada 2
and then
lubang
you have
apa?
the stainless steel, and then you need an insulation.
Oh,
Oh,
insulation dia kuning.
insulation. Yang satu
Okay.
lagi.
So this yellow one is
Tak
insulation.
roger tu.
So the
Buat apa
grid
ni? Faham.
thickness is 2 centimeter because inner diameter is 4, outer diameter is 6. So the thickness is 2. They're asking you the thickness that is required for the insulation. You read, yeah? Yeah, here. First, justify the
tinggi tu.
specific type of
Duduk.
insulation material that
Murah.
you have selected. So what shall you do?
Bom ni kat
Go
luar tu
here.
mahal dah nak.
And you go right and see.
Milo,
Properties.
Milo,
Yeah?
Milo.
Need to
suam.
check the properties
Jangan
of
burn.
insulation material. Let's see. Boiling, freezing,
Tahu.
solid material, solid metal, solid non-metal,
Apa WhatsApp ni suka aku.
insulating material.
Ya,
So
bodoh.
the insulating material was suggested to be
Saya ada yang siap.
spray or foam in place
Diam
type.
je lah.
Yeah.
Hai.
Let's look. Spray. Forgot what.
Ah.
Spray or foam type of insulation. What do we have here? Board and slab, blanket and part, loose fill,
Macam mana dia buat ada
perlite,
oh dia dah siap letak bookmark.
perform for use above deck, reflective ventilation.
Macam
Anything
elektronik
else?
ni. Tak mampu
Oh,
lah
there.
iPad aku ni.
Charge
Notice
dah lalu main sekarang. Kau
spray
buat
or
belajar
apa?
foam in place. So which one?
Kan tengah buat
Do
nota
you
tu.
use polyurethane,
Kau buat nota ke main?
glass fiber,
Nota tu.
urethane,
Nanti
mineral
share.
wool? Okay, look at the K.
Tak boleh tu.
Do you need a low conductivity insulation or a high conductivity
Mainkan
insulation?
kau aku baik.
It's Prem here or
Boleh
it's not
tu.
Prem?
Buat ah.
Navindra ni ah?
Habiskan bertepas sebab budak tu bagi aku tak bertepas
Okay,
babi.
which one would you choose?
Oh,
Okay.
Main akaun aku dia Pat, naikkan plat.
boleh tu.
Why?
20 setiap kali 20 lah RM10.
Anything in that range is
Pak.
also acceptable.
Dia buat
Just
duit
So
tu.
why you choose
Boleh lah aku mainkan
polyurethane foam? Why
RM5.
not glass fiber?
Bagi
Why
lah
not
password.
urethane?
Aku okey
Why
je.
not
Warna
mineral
biru
wool?
RM5. Boleh kau pakai elder frame dagger baik. Mainkan aku.
Alamak.
Alamak.
Z Phantom
Dah
pun.
siap.
Let's see the question again.
Tak
Yes,
sumpah
Surang
ada
apa?
account tu kan.
Here,
Gold 3
justify
sekarang.
the
Aku main
specific
3 game
type of
semalam.
insulation material that you have
Murphy.
selected.
Account dia tu kan tak banyak skin tau tapi
Yeah,
mahal.
give you
Sebab
a choice.
skin mahal babi dia
So
beli.
you went back and
Sebab
you
knife
check,
tu
wah,
single
Knife
boleh.
sini
dengan
ah.
Phantom
So you
pun
have,
mahal.
I have polyurethane, I have glass fiber,
Tapi ada
I have
VP
urethane,
1000.
I have mineral wool. I have 4 choices.
Faham.
Habis apik pakai ya.
Tunggu bodoh tak payah bodoh. Tunggu naik market dulu nak
Navindra decided to
Kau
use
beritahu aku nak
polyurethane.
tekan
You
apa
have
je
to
sorry aku
justify
tekan
why.
je.
Because the question said,
tak payah bodoh.
justify the
Simpan buat apa?
Kau
specific
beli
type
skin
of
bodoh,
insulation
Nak jual balik
material
tu
that
bulan
you
depan.
choose.
Skin
Kau
sekarang
banner,
lah.
banner.
Skin sekarang.
Bodoh.
Maybe
Skin tak ada
because,
animation.
polyurethane
Lawa.
is easily available and
Gila baik semalam
Oh,
keluar
you
River
don't know
Vendor.
that?
Tengok hari ni keluar perang
Next to
Vendor.
me, lots of glass fiber.
Terus.
Tepak kan. Tepak.
Lucky,
Nak
of
ah.
course, but you know, it's not
Keluar
academic
RGX
answers.
beli lah.
Ah.
Kat night
Okay,
market keluar.
Keluar.
Azlin,
Aduh doktor.
I
Dia
only
tanya
these
apa
5
bodoh?
students who keep coming to my
Astaga.
class. Yeah, the rest I do not know yet.
Oh,
Apa kita tak ada nak eh.
ayolah.
Yeah. Which one would you choose for an insulating material?
PVC.
Oh, nama kita tak ada.
Dia tak update lagi.
Glass fiber, why?
Tidur balik lah.
Because it's
Ush.
used in industrial.
Glass
Is
fiber
this
mat.
used industrial?
No, but I
The question is quite neutral.
Dia tanya apa
I
ni?
like
Okay.
I like the name.
No problem. Yeah, I'm the what you call the third wheel. You know, I'm or what you call the
Polyurethane
spoke
lah.
in the wheel. You know, the devil's advocate. Yeah.
Let's spend
That
that
means I
rubber.
question you so it makes you wonder.
Boy.
Yeah, don't just select. You have to think. If you select something, you have to justify.
You have to
Okay.
think.
Justify. I like the
Izul
material.
here. Prem, you want to try?
Prem memang anak betul tu.
Yes,
Let's
doctor.
go, Plum.
Okay, go ahead. Prem will get
Uh,
extra marks to jump grade next time.
No need, doctor.
Oh, no need. Okay, fine.
I think, doctor, because the question want to have less convection to be happening and due to reduce the heat loss, I will choose
Kami
the
memang engineer.
lowest stage, doctor. The lowest coefficient because it will give me the lowest convection. So I will choose the
Conduction. Lowest conduction. Because through the solid is conduction.
Yes, doctor. Lowest conduction. So I will use the polyurethane form, which has the 0.023, the lowest in this category.
Yes. Okay. So you choose that. So that's your justification. So justify. You would have selected the polyurethane foam because it has lowest thermal conductivity compared to the other three types of insulation.
Memang nice,
You must
Prem.
justify. You don't know whether it's cheaper. You don't know whether it's around. You know? So that. Okay, then determine the percentage reduction if heat loss, if a 2 centimeter thick insulation of your choice is installed in this pipe in percentage. It's quite lengthy. So you already have stainless steel pipe of 2 centimeter. Now you added another 2 centimeter of insulation. You have to determine the heat loss. For the heat loss in this case, with your assumption steady state, no heat generation, constant thermophysical properties, one dimensional in R, so your boundary condition, you have to look at it, see. You need to find the heat loss without the insulation and with the insulation. You need to find Q, to find Q through the stainless steel pipe. So you need boundary condition. Here, you see, it's given combined heat transfer coefficient 20, loss to the surrounding at 30. So you have the boundary condition on the outer wall at 30. So let's have a look at the combined. It's in your textbook probably also, but it's not combined. Maybe it's the part 1. Let me see. Basic. Okay.
Welcome back.
This one. Combine. There. Combine. So H combined is given. And then you have
Chapter 1 pun lain je dengan kita dia bagi kita.
natural convection relation with the combined heat transfer.
Tak payah ni
The heat
chapter
from
2 ke yang
the
soalan
loss to
tanya
the
ni?
surrounding at 30.
Tadi
So
dia
if you
refer
look at
tadi
that,
chapter 1 nya
the
notes tu
surrounding is
lain
at
siap.
30.
Kan ke
The
sama?
T surface, you have to find the T surface
Tak sure tu.
13 page man.
first.
Tak sure dah, Man. Yang tak sama lah tu.
Dekat kita 3
I
page je
think
kan?
this
Ke
is
2?
H convection.
Dia 13
mistake.
apa?
You have to look at this. This one. Yeah. You have
Tak,
that
kan
equation
cakap kita punya
129.
review, bukan yang
H
note dia.
combined is given.
Tak
TS is
bagi je
given.
lah
T
tu.
infinity is given. So you have Q total.
Kan ada dua kan, satu
What is
yang
the
dia bagi dia
surface
yang
area?
besar review.
2 pi RL. You don't need the L because you want to find the percentage loss. Yeah, the L remains. If a 2 centimeter, okay. So you can do that. Let me see. You have 20. What is the surface temperature? Surrounding is 30. So you have to find the surface temperature here. Temperature of the steam at 25 degrees C. Okay. So what is the outer surface temperature? It's a bit sticky. Yeah, so here you may assume this is 250 without the insulation. What is the heat loss? And then with the heat loss. See whether I have the solution. It's easier for me rather than what is the solution. Let me see.
Dah tak ingat tu macam mana.
Oh, I don't have the solution. You can see here. This one use thermal resistance. No wonder you cannot solve it like that. You have to use the thermal resistance, which we'll cover next week.
Ada jawapan
Thermal resistance is covered in test 2. I mean test 1, sorry. So this one is thermal resistant. It didn't say, but you have to use it thermal resistant. For question 1, let me find the solution. There is any. Question 2, answer, test rehearsal guide. Oh, they didn't share with me. The lecturer didn't share. No. Tak ada. Okay, that's it for example. Yeah. So I cannot assign that. I may assign this one as a homework. You have a test on Thursday. So after that, I will assign a homework based on just conduction. Yeah. So
First,
that's it.
ada apa?
Just have a look at the.
Quiz.
Do I have
Soalan
any more
Test
examples?
juga.
Because
Test
my
one
pen
ni kau
drive
nak.
got corrupted.
Ya ke
So
Fadil? Salah cakap.
Ya ke?